Hello and welcome back to another episode of Looksies. This time we're looking at Sprocketnes. It's a project that has been seeing its first commit in January 2013, and I think it was more like a demo showing that Rust is indeed suitable for system-level programming and low-level stuff. Sprocketnes. I think there is an emulator called Rocketnes, which is kind of the state of the art and works on Windows and Linux and everywhere. Maybe only Windows, but I don't know. And this one is kind of based on this. It was created by PC Walton, who is a well-known figure or person in the Rust community. So one of the ones, one of the old ones, basically, who has been there with the language for a long time. Well respected and, an able programmer. However, the original version hasn't seen much love. So the last commit was authored in April. Okay, that's interesting. Because basically this one doesn't work anymore. And there are a few pull requests open. And so far, no reply, but maybe this project can be revived in some way. In order to get it to work, to get it to compile on stable, you have to definitely pull in this PR yourself. And I have been in a conversation with Jonas Schivink, with Jonas, who has been doing some amazing work to get this back online and even implemented a mapper which makes Cobra run. I don't know what a mapper is, but previously it didn't work. So I pulled in all of these patches, and now it actually works better. Let's say it works better. You can run Contra pretty well. And it seems there's plenty of stuff still unimplemented, so some games really use hardware in some way that is just not supported by this emulator. Here it's more like a demo, but I would really hope that this eventually becomes more, or becomes a maintainer at least, right? So what is Sprocketnes? I think the best way to show it is if you start it. So cargo run release, there's not too much to it. You can scale by 3 and then you provide the path to the ROM here. I once again downloaded a few, and Legend of Zelda is an amazing one. Unfortunately, you can't play it. I don't know if you hear the music, but that music makes you shiver. That's something you have probably heard at some point. So here you see it uses like 47 megabyte in RAM, 25% CPU to do that. Probably there's some optimization potential. Oh yeah, and what you see is that this stuff somehow doesn't work. And this one will crash when you try to run it. But yeah, eventually it will crash, but at least you hear the music. And there we go. So now it kind of hung up and things stop working. But the music is already great. You have audio support. Let's have a look at another thing. Mario. Unfortunately, there are some visual glitches here. And also, I think you can't play it. It will freeze in the moment you try. But you can see some demoing going on, I believe. And then the moment you do that, you kind of realize that something doesn't work with the colors, maybe. And alpha and whatnot. So yeah, let's see if we can see a bit more here. Eventually, I thought it would show some demo here. Come on. Show me the first level. Do it. What's quite amazing is that, let me put this into the background here, that these ROMs, they are 128 kilobytes in size, or 384 kilobytes in size for a game. That's so amazing. Sure, Mega Drive was the same thing, really small, but yeah. Okay, so it starts fresh. If you try to start it, unfortunately, it will crash. Unimplemented or illegal instruction. Well, at least you know what's happening. So the CPU is not fully implemented yet. Would be great if it would be, because these games are actually fun. You wouldn't believe it. The one that works perfectly so far is Contra. With full sound. with full sound and keyboard inputs. I think this is the work of Jonas as well. So I will try my best here. Yeah, so again, Alpha seems to be a bit funny, and as you can see, these bullets, they kind of are split in the middle. Oh. Yeah, and you kind of can only... Yeah, you got me there. Oh, interesting. I can't jump now. Uh-oh. Uh-oh. Okay, so you have to wait for a platform to get out of there. Do I get something here? Ah, I see. No, I find death. Uh-oh. And I just picked something up that I lost immediately because I was dumb. Because I was dropping in front of a cannon. Well, this game is hard. But it's all a matter of training, I think. Oh my god, die. Die already. And it's quite tense as well. Okay, I guess that's where you... Oh no! Oh my god, I'm still alive. So, my first better weapon. Give it to me. Awesome. Die. I think that's one of the best weapons, huh? Spread shot. Don't die while jumping. Oh. Uh-oh. That's a flamethrower. And there I was dead. Game over. I shall end this because I'm not worthy. I can't... Yeah. In the menu, for some reason, this doesn't really respond anymore. So there's plenty of stuff that doesn't work. But it's still fun. There might be other games that work better, or you might be the one who's able to fix this thing. I have no idea. We can have a look at the code. That's the latest one that was prepared by Jonas, by the way. So stuff was a bit split up into a library here and a binary. And yeah, let's have a look at the maybe audio processing unit, huh? Oh no, maybe the CPU. What's a PPU? What's MEM? I have no idea. Let's have a look at... Where's the CPU? CPU-RS. Okay, so that is a CPU emulation. Wow. I have no idea what that is. Cycle table. I'm wondering, you know, sometimes you lose a lot of efficiency because access to arrays are always checked. And I think if you would do a get unchecked here, then this could even be faster, huh? Get unchecked. I mean, sure, we don't have a benchmark really, but if this would be hot code that I don't even know, then this would certainly speed things up. I made good experiences with that, so that's unsafe. But still, let's try it just once. And wow, lots of vector pushing happening here. Yeah. Interesting. This is a CPU. Did you know? I didn't. Man. And yeah, where's the mapper that was implemented recently to make Contra work? Because that wanted to use this mapper. It defines the mapper trait and mapper implementations that are used to translate CPU addresses to addresses on the cartridge memory. Oh yeah, mapper 2 or something. I think that was the one. That wasn't there, but I have no idea how this works and what works. I think one of the last here added mapper 2, so let's see how that is implemented. How do you implement a second mapper? You just put it there, and then yeah, interesting. And then you implement it, of course, whatever that means. Interesting. I don't know how that works and how people can make it work. That is above my head. You probably have to study chip design or engineering and need a larger brain than I do. But I'm happily using these guys. I can compile them and play some old games that are still quite adorable. If you want that too, feel free to mix into this thread here, and maybe something good happens, right? So thanks for watching and have a great day.